Hi, in this video, we will be going through three questions adapted from past papers regarding finding the gradient of a tangent to the curve, finding the points on a curve such that the gradient of the tangent is a specific value, and the equation of the tangent to the curve at a specific point. We'll be using the fact that if we substitute in x equals a value such as 3 into the first derivative of y with respect to x, we will get the gradient of the tangent of the curve at that point. Question 1. The curve C has the equation y equals x squared plus 3x. Part A requires us to find dy over dx, or the first derivative of y with respect to x. Dy over dx is equals to the derivative of x squared, which we can write it as d over dx of x squared, plus the derivative of 3x, which is the same thing as 3 multiplied by the derivative of x. To find the derivative of x squared, we use the power rule. So we bring the power to the front and then minus 1 from the power. And similarly, we have 3 times the derivative of x. So x is x to the power 1, so we bring the power to the front. So we bring 1s down to the front and then minus 1 from the power. This can be simplified to 2x to the power 1, which is simply 2x, plus 3 times by 1 times by x to the power 0, and x to the power 0 is simply 1. So we have 3 times 1 times 1, which simplifies to 3. So therefore, for the curve y equals x squared plus 3x, the first derivative of y with respect to x is 2x plus 3. Part B requires us to work out the gradient of C at the point 318. This can be done by substituting in x equals 3 into dy over dx. This is because the first derivative of the curve with respect to x will give the gradient of the curve. So therefore, at x equals 3, dy over dx is equals to 2 multiplied by 3 plus 3. 2 times 3 is 6, and you plus 3, and this will give you 9. So the gradient of C at the point 318 is 9. Question 2. The curve C has the equation y equals 2x cubed minus 6x plus 4, and part A requires us to find dy over dx, or the first derivative of y with respect to x. So dy over dx is equals to the derivative of 2x cubed, which is the same thing as 2 multiplied by the derivative of x cubed, plus the derivative of negative 6x, which is the same thing as negative 6 multiplied by the derivative of x, plus the derivative of 4. And the derivative of any constant is equal to 0, and therefore we won't write this down. So therefore, we have 2 multiplied by the derivative of x cubed, and we can use the power rule again. So we bring the power to the front, bring 3 down to the front, then we minus 1 from the power. So from x cubed, we go to x squared. And similarly here, we have minus 6 multiplied by the derivative of x. X is x to the power 1, so we bring the power down to the front, and we minus 1 from the power. So from x to the power 1, we go down to x to the power 0, and x to the power 0 is 1. So therefore, we have 2 times 3x squared, so we have 6x squared minus 6 times 1, which is negative 6. So therefore, dy over dx of y equals 2x cubed minus 6x plus 4 is 6x squared minus 6. Similarly to question 1, we can work out the gradient of the tangent of C at the point 24 by substituting in x equals 2 into dy over dx. So therefore, at x equals 2, dy over dx is equal to 6 multiplied by 2 squared minus 6. 6 multiplied by 2 squared is 6 times 4, which is 24, and you take away 6 to give 18. So therefore, the gradient of the tangent of C at the point 24 is 18. Part C requires us to work out the x-coordinate of the points on the curve where the gradient is equals to 7.5 or 7.5. So this is equivalent to finding the value of x such that dy over dx is equals to 7.5. So dy over dx is from part A is equals to 6x squared minus 6. So therefore we have to solve 6x squared minus 6 equals 7.5. So we have 6x squared minus 6 equals 7.5. So we'll add 6 to both sides to give us 6x squared equals 13.5. And from here, we'll divide 6 from both sides to give us x squared equals 13.5 over 6. And 13.5 over 6, we can write it as 9 over 4. And then we'll take the square root of both sides to give us x equals the square root of 9 over 4. However, whenever we take the square root, we have to consider both the positive result and the negative result. So therefore, our result will be plus minus the square root of 9 over 4, or in other words, plus minus 3 over 2, or plus minus 1.5. Question 3. The curve C has equation y equals x cubed minus 4x squared plus 3x minus 4. And part A requires us to find dy over dx, or the derivative of y with respect to x. So dy over dx is equals to the derivative of x cubed plus the derivative of negative 4 times by x squared, which is the same thing as negative 4 multiplied by the derivative of x squared, plus the derivative of 3x, which is the same thing as 3 multiplied by the derivative of x, plus the derivative of negative 4. And the derivative of any constant is 0, and therefore we won't write this down. So the derivative of x cubed, we can use the power rule here again by bringing the power to the front. Then we take away 1 from the power. So from x cubed, we go down to x squared. And we have negative 4 multiplied by the derivative of x squared. Again, we'll use the power rule. So you bring the power to the front and minus 1 from the power. So from x squared, we go to x to the power 1, which is the same thing as x. And lastly, we have 3 multiplied by the derivative of x. And the derivative of x is equals to 1. So therefore, dy over dx is 3x squared minus 8x plus 3. For part B, point A is a point on the curve C with coordinates 2, 26. And we have to find an equation of the tangent to the curve C at A. And we have to give our answer in the form of y equals ax plus b, where a and b are some numbers. So an equation of a straight line can be written as y equals mx plus c, where m is the gradient or the slope of the straight line and c is the y-intercept. So the gradient of the tangent to the curve can be calculated by substituting in x equals 2 into dy over dx. So therefore at x equals 2, dy over dx is equals to 3 multiplied by 2 squared minus 8 multiplied by 2 and plus 3. 3 times 2 squared is 3 times 4, which is 12, minus 8 times 2, which is 16, and we add on 3. So therefore, the value of dy over dx at x equals 2 is negative 1. So this is the gradient of our straight line. So we can write our equation of the line as y equals negative x plus c. And now we have to solve for c. A point on this tangent is also point A. So therefore we can substitute in x equals 2 and y equals 26 to work out the value of c. So we have 26 equals to negative x, which is negative 2 plus c. And we can add 2 to both sides to give us 28 equals to c. So therefore c is equals to 28. and the equation of the tangent to the curve at A is y equals negative x plus 28. Here are 3 questions adapted from past papers that I want you to try regarding finding the gradient of the tangent, finding the x-coordinates of a point on the curve, such that the gradient of the tangent to the curve is a specific value, and finding the equation of the tangent to a curve at a specific point. The answers will be given in the description below. Good luck!